So hey guys, my name is Miro Horvat. I am a senior technical artist at Bohemia Interactive in a Prague office, and today I'm going to talk about game asset production pipeline for our recently released project called Arma Reforger. So the topics. After introducing myself, Bohemia Interactive and Enfusion technology, I will go through some game dev technicalities. So even for non-gamers or non-game developers, is this talk easy to follow? After that, I will go, after that we will have a look at how Blender is used at Bohemia Interactive. I will give a quick insight to game asset creation process for Arma Reforger and what's enfusion Blender tools and its features. So let's start. I've been using Blender since, well, this graphical user interface, it's year 2005. I actually got to Blender because it had its own game engine. It's simple as that. Same as Martin's. Since I joined Bohemia Interactive in 2007, I also started scripting with Blender's Python API, and through the years I've been using Blender for various projects, mainly creating virtual landscape for Arma series or military simulations. So this is actually my I had a talk in 2016 here at Blender conference about the add-on called Blendscape Tools that I developed to help me create virtual landscapes for game and military simulators. This is actually my third talk at Blender conference already. Last 7 years I work as a technical senior technical artist, and I've done lots of R&D for our new proprietary game engine called Enfusion and the Arma Reforger project. I'm also quite active in geometry nodes since the day one, commenting on patches, discussing ideas at DevTalk, testing, making YouTube videos, and here's few of my geometry nodes experiments. You may know it from my YouTube channel. So this one is trying to generate flow maps with mental flow together with geometry nodes, get it into game engines. I did it for RPG, Godot, and Unreal, I guess. Yeah, this is few more videos, and this is faking a LiDAR sensor on a self-driving car because I had time to play with that. Okay, not again. Yeah, and in my free time, I use Blender also for 3D printing stuff and having fun prototyping simple games with my son in UpBG. That's how I pronounce it. Okay, so let's talk real quick about Bohemia Interactive. It was founded in 1999. We have 4 offices in Czech Republic, 1 here in Amsterdam, and Thailand, and we have around 350 employees. So Bohemia Interactive has under its belt such titles as original Operation Flashpoint, Take on Helicopters. These were made on or with a real virtuality engine. Vigor, that one is made with Unreal Engine. Violence, that's a Unity engine. Daisy, also the old real virtuality engine, a bit combined already with enfusion. and finally, and of course, Arma series. The last project in Arma series is Arma Reforger that was released as early access in May this year. And it's first game fully made with our new proprietary game engine called Enfusion. And Arma Reforger is predecessor to Arma 4. You can see it on the timeline. And here's the trailer. Maybe with sounds, if it is possible. No. Anyway, let's enjoy it. Mentioning all of those our games, I would like to emphasize that most of our games are heavily focused on modding. In other words, we allow our community to add content to games, either it's new models, textures, gameplay, up to a new open worlds. For example, Daisy has started as a community mod to end up as a standalone game with its own team of Bohemian Interactive developers eventually. Okay, so let's quickly talk about enfusion engine. So two of our own proprietary engines, Real Virtuality and Enforce engine, got fused into one, and that's our new enfusion engine. The development has started roughly around 7 years ago. So yeah, so these are the games, I already mentioned them, made with Real Virtuality engine. These are the Enforce engine games, Shades, Alpha Prime Command, Carry Command, and Take on Mars. And this is how the main tool looks like. It's called Workbench. So if I mention Workbench in this presentation, I mean this tool, not Blender's render engine. And so actually Workbench allows user to preview whatever game asset, either it's mesh, textures, materials, config files, and it's also a main hub from which user can get to all the editors like word editor, particle editor, animations, procedural animations, string editor, behavior editor. And here's just a really short advert of Enfusion's modding capabilities. Okay, so let's go through a very light game dev theory. So first thing, LODs. You probably may know it if you work in a game dev. So simply put, it's a mesh decimation to achieve better performance. In other words, to not render details that can't be seen at a certain distance. So lower the number of LOD, better the quality is. So this is LOD 0, this is LOD 5. Each LOD you see is a separate mesh that is being replaced by another. And this is nothing like dissolving vertices in real time. Yeah, and here you can see the LOD switching in the context of open world. So objects without the colored overlay are the most detailed meshes. Red overlay is first load, green second, blue third, and so on. Switching is not based only on a distance from camera to object, but also on what area a specific object covers on the screen. Therefore, bigger object switches to worse LODs later than smaller objects. Okay, another one, it's colliders. Colliders are used in physics simulation, and for the best performance, these must be easy to describe mathematically. So a box can be just a diagonal through the box. Capsule is just radius and height. Sphere is just the radius. Cylinder, again, radius and height. And then it's like convex collider. And in some cases, when asset is topologically complex, triangle mesh type can be used, but it has to be used wisely. Yeah, and here's a example of how the colliders looks like for this specific model. Yeah, and here again you can see how physics simulations see the world of colliders. They are color coded, so the blue ones are convex. Sorry, they're a triangle. No, blue ones are convex, purple are triangular, and the green ones are box colliders. Yeah, and another one is occluders. So I hope, yeah, it can be seen. So these are planes which basically occlude everything what's behind them. Occlude means not render, so it's again for increasing performance. Here you can see that it can't be placed into the windows, because if you would look out of the window, you wouldn't see anything because everything would be occluded. And now you can see, yeah, those bounding boxes. These are the bounding boxes of every object placed in the open world, which actually got occluded, so not rendered. Okay, let's move on. So shaders. Shaders you already know from Blender. This is basically a material used on a mesh. In enfusion, we have a plenty of shaders for various games, assets like post-processes, objects. Yeah, there are like tree trunk, tree crown, terrain objects, a few more for terrain and for water, ocean simulation, and so on. Yeah, and this is our most complex shader called PBR Multi that mixes 4 materials together via masks, and plus allows to overlay some VFX layers like dirt and mud. As you can see, there's a lot of textures that comes in. I guess for this one, it's 21 textures. Yeah, in our shaders, we use, as I already mentioned, a lot of textures and various types of textures based on the texture type. In other words, it's suffix, like in this case, underscore NMO. A specific way is then specific way of image channel compression is chosen during conversion. Conversion actually means to convert a source texture, either it's PNG or TIFF, into internal format suitable for rendering in real time. In our case, it's EDDS format. And during conversion also MIB maps are created, what's basically something like LODs for textures. Yeah, and this is the example of NMO texture. It holds information about normals in red and green channels, metalness information in blue channel, and occlusion information in alpha channel. Yeah, there are, like, as I said, a few more. For example, BCR, that's like albedo, basic color in RGB, and alpha channel is roughness. Okay, let's talk about what prefabs are. So simply put, it's a collection of game objects that are grouped together that you can instance in games world. So here we have a base mesh of a church, so without windows and any doors and any additional stuff inside. And in a moment we will see what's already a prefab. So it has all the stuff in it, and it's ready to be instanced. So the advantage of it is if we change something within the prefab, so either we add something or remove something or add some logic, some meaning to these objects, those changes gets applied to any instance of that prefab placed already in the world. Okay, so yeah, I guess this is it for technicalities. One thing necessary to mention that all these all these technicalities I've just gone through are specific, aren't specific to our engine. All the aforementioned techniques, aforementioned techniques are used in other engines as well. Just the implementation and usage may vary. Okay, so let's talk about Blender at Bohemia Interactive. So we have over 25 Blender users. I haven't counted a few programmers who also are capable of dragging vertices around, so they can prepare simple meshes for debugging or testing engines, technology prototypes they are currently working on. And the rest of the artists are using other 3D packages. Even though Blender is a powerful tool, without the add-ons made by Blender's great community, our game assets creation pipeline would be tedious and time-consuming. So let me thank you to developers of these great add-ons we are using. It's very helpful. Yeah, how do we use Blender? So, of course, mainly we use it to mesh modeling from small props like vegetables, beer bottles, to bigger objects. Let's call these vehicles. vegetation and to big structures like this church. Oh, okay, not there, but we will get there. So yeah, we also use Blender as a asset quality assurance tool, but I will talk about it a bit later. So we use also Blender to make compositions of our assets and render them as images for example, this is from Arma Reforger website. Our video team used it to render some scene for trailers as well. Here's a short shot from a bigger trailer. And here from Daisy trailer, we used self-fracture add-on and then physically simulated the fragments. Yeah. Also, our operation department does pre-visualization of offices before reconstruction actually happens. Yeah, this is set up from another office. Yeah, and also we do some pre-visualization of merge. So I, as a technical artist, do a lot of technical research with Blender. You could already see something in the video at the beginning. And in the future releases of Arma Reforger, we would like to, or we will also bring buildings destruction. So currently I'm prototyping geometry nodes powered tool to help us cut buildings assets into fragments. Yeah, so let's talk about game asset creation process. Typically, process is modeling high-res meshes, making UVs, and then making LODs out of the high-res one, and doing or making other separative meshes like I already showed you, colliders, occluders. When creating LODs, we don't use decimate modifier at all, as it's quite unpredictable, and especially with objects where silhouette must remain constant through LODs. I've been also told by our artists that decimate modifier breaks UVs. So instead of using decimate modifier, artists dissolve vertices and edges. So good old manual labor to make LODs optimized as much as possible. So artists have to set up objects before exporting to enfusion. For example, to let enfusion engine to recognize LODs objects within FBX. They has to be named with suffixes or prefixes. So in this case, prefixes are for colliders, suffixes are for LODs. Also, they have to configure colliders. So each collider must have its game materials, as we call it, assigned, that defines, for example, what sound to play when hit, what particles to emit, or what bullet holes decals to place where bullet hit the collider. Another thing we set up is layer presets, which defines what objects to collide with. So here you can see there's a wood.gamemat. And after this is all done, artists should do validation, but that's not the case in every case. So also, they sometimes don't do it, but they may also do a mistakes, like mesh having bad topology. So there are, I call it zero length edges or zero area faces. This may happen during the modeling or maybe using some modifiers. Also, when modeling convex collider, it may happen that actually eventually it's not convex. Or colliders that's supposed to be closed volumes having non-manifold edges, or making typos when naming objects. Yeah, when duplicating objects, they forget to remove our beloved .001 suffix. This is a problem, as I said, because when importing FBX into enfusion engine, this .00 gets behind the LOD, so it's not recognized then as a LOD. Oh yeah, and the same problem with .001 kicks in also when importing assets made in Autodesk products that allow to name several objects by non-unique name. Anyway, when configuring colliders, they may also do typos or completely to forget to, for example, fill the layer presets. That's a custom property. And how we help to overcome these problems, I will be talking in a moment. Oh yeah, I even have a screen picture of it. Yeah, and after validation, artist is allowed to export to FBX. FBX. So we use FBX as a main exchange format among all 3D tools we use in Bohemia, and we also use it to import stuff into enfusion. During the production, we also had to solve some problem how different 3D tools manage normals. Everyone does it a little bit like differently. So to have all of our assets shaded properly without any visual glitches, we use weighted normals modifier in all 3D packages. Maybe it's not called the same one, the same as in all of them. And yeah, weighted normals also led us to avoid of making additional edge loops for better smoothing, thus decreases poly count, and that's what we want for real time. And yeah, FBX lifecycle. So we have to be able to open any asset store in stored in FBX in any 3D software by our artist. Because, for example, one does model in Blender, and let's say his manager needs to do review in Maya, for example, or happens that artist leaves a company and someone else has to overtake this asset, and he uses completely different application. Yeah, so this is the life cycle. And as you may already guessed, it's not always a painless process. It hurts. What happens, Autodesk users using groups and layers lose them if FBX is resaved with Blender, or vice versa, if Blender user lose collection. They typically use it for a better organization of the scene, especially when there's really hundreds of objects. In some cases, when using wrong FBX version, when exporting from Autodesk products, custom properties got lost. And this was really tricky to figure out because these custom properties are, hidden. It's not really visible that they are not there. So we just found out when we import it to Enfusion and something wasn't working. Oh, oops. And added bone. Some of you may know of this phenomenon when importing FBX with skeletons into Blender and exporting it back to FBX. Blender adds one bone. And then compatibility with Autodesk products is broken. It actually also got broken in Enfusion. This breaking animation thing in Enfusion was fixed during or on the side of Enfusion during import, but the problem is that it's still in this FBX lifecycle. So if someone opens the skeleton in Motion Builder, it's broken. For some time, well, internally we use Better FBX add-on, which solves this. I would get inspired, but this it's actually, well, it's add-on, but it's just an exe file. I can't take a look inside. Yeah, and oh yeah, I have my other notes here. So I would like to mention vegetation creation process, because vegetation is all vegetation assets were made purely in Blender. So when I asked our artist why we haven't used other commercial tools for procedural tree creation or generation, back then, 2-3 years when there was pre-production, they weren't able to cover whole pipeline in one tool, and in Blender they were, unfortunately manually, but they were able to do it on time. Yeah, so here's a quick look at how it's done. So typically we first bake foliage atlas textures. All these textures are either taken by camera, or we buy 3D models on internet and render them. Then we build 3D branches from those atlases. That's the top right image. And after that, we build a whole crown out of these 3D branches. Yeah. We also experimented with 3D scanning of the trunks because in a first-person shooter, when talking about trees, the trunk is most visible part from a tree, because player can reach it easily. So that's why we pay attention to details at these lower parts of trees. Yeah, and when I said that this whole workflow was manual, there were actually a few scripts written actually to automate some parts of the development. Okay, and let's move on to Enfusion Blender tools. So, because of previously mentioned issues, as well as time-consuming and tedious pipelines, we decided to develop a tool to increase productivity of our internal artists, as well as community of modders. And enfusion Blender Tools, or EBT for short, is a typical Blender add-on installed from a zip file, and his features can be found here and there. Currently, the add-on is available on Steam as part of Workbench or enfusion tool suite. Currently, most of the features are bound to Arma Reforger, but once we have more features that would be handy even for Blender community, we will release it probably on a GitHub. So let's talk about EBT features. So the first one is a model quality assurance feature that checks through every game object in the blend file and reports on objects having invalid data. For example, in this case, usage property or the layer presets I mentioned on colliders is empty, or layer preset name from a predefined predefined list isn't used. User can select the object and fix it via object tools. Another feature I will get to it in a bit. And in case user checks one of those mesh topology checks, besides it reports on objects with invalid meshes, it also automatically assigns a mesh validator, which is a geometry nodes modifier that shows issues in real time. What I mean by real time, it highlights invalid topology and in the reports how many such issues is present. And the cool thing is that you can see how it is being fixed in real time. So yeah, the overlay got removed because it was fixed. In this case, it was the non-manifold edges, and you can see there's like 0 issues. Okay. Yeah, and so cool thing also about having it really like real time, like changing, for example, the face area, is that besides you can or it can mark those zero area faces or 0 length edges. You can basically drag the slider, because sometimes it's not just really all 3 vertices at one place, but it may be a really small one, very small face, but it's invisible because this is really simple geometry, but huge structures you can't find it there. So you can basically drag the slider and identify all the issues, all the cases. So yeah, you probably remember this one. So so this this issue basically gets also checked and reported. So user can easily fix it. Otherwise, .001 suffixes would cause, as I mentioned, the problem with LODs recognition during the import. Yeah, batch FBX export. So when artist creates asset from scratch in Blender, it typically does the base mesh, as on this picture, and also all the additional stuff. So he has the reference how big the doors, windows should be. And as you can see in the outliner, there's tons of them, and all of these base mesh and the additional stuff has to be exported to separate folders, to separate FBX files. Yeah, so you can see it here, and therefore we added batch export, batch FBX export. So where user basically just selects the collection which he would like to export, says the folder, and press batch export FBX, and all the FBXs get exported into the folder. Yeah, material preview feature. This one mimics enfusion shaders I already showed you in Blender to visually assist users while creating a model from scratch or to help creating additional data like baking textures for last LODs and more. Here's a example of PBR basic shader in Blender. So on left there's Blender, on right there's Workbench. So not Workbench in Blender, but other Workbench. And here's PBR multi. So this is how all the shaders inputs look like. There's UV sets, sources, UV transformation for each texture, and so on. And yeah, this is the guts of PBR multi shader. So at the beginning there's masks processing, as I told you that you're using masks to blend all those four materials. There's color processing, which is basically albedo textures, roughness processing, metalness, and at the bottom normals processing, or normal maps processing. And at the end, all of this it's plugged into Principal BSDF shader. Okay, so let me quickly explain why I said material preview only mimics enfusion shaders, and it doesn't give exactly the same visuals as in enfusion. So you already know, also Martin's mentioned it, that we can't write shaders in GLSL and compile it. So we have to do it with node editor or shader editor. So therefore, it's quite challenging task. Excuse me. Also, the implementation of PBR, it's a bit different, or maybe quite different in enfusion and also in Blender. Unfortunately, nodes that would give, for example, gbuffer information are also missing. We use this information for our decals shader in enfusion. Also, the way how Blender treats alpha information is a bit different than in enfusion. For example, alpha test or alpha clip is not allowed in alpha blend mode. It's only available only in alpha clip mode. Oh, okay. Now I'm not sure what is this video about. Ah, okay. I see. Can I stop it? Yeah. Yeah. Also, actually, another problem is that shaders in Blender use source texture as source texture formats like PNG or TIF, whereas shaders in enfusion uses compressed EDDS textures, and because of compression, there may be visual differences spotted. Like, for example, on this picture. So when playing with alpha clip slider, in this case, the same number for alpha testing and multiplication are used, but it gives a bit different result. And also because of all these aforementioned issues, we can't support all enfusion shaders parameters via material preview. So as you could see on the PBR multi, the big one, we support just a small fraction of it. Okay, so let's have a look how we actually get textures or the assets with enfusion shaders into Blender. So all user needs to do is import asset via our custom FBX import. Here you can see just the reports that some of the materials are not supported, as I mentioned, and also it may report that some source textures like TIF, PNG is missing. You can also see in the outliner that custom FBX import also creates dedicated collections based on what meshes are in the FBX. So it creates LODs collection, colliders collections. So it's easier to navigate in the outliner. Yeah, and via material preview feature, users are also allowed to edit materials, imported materials. For these custom panels were added into the material properties, but editing material properties is only local right now. It means that the changes can't be exported back to Workbench, but we're trying to figure it out. Yeah, but still user can do the edits in enfusion. Like can change the UVs on this material and the color on this one. The materials has to be saved, and yeah, and then just click the update materials, and you can see the changes in UVs and the color. Yeah, and so in case an artist is is not getting what he expects to get while setting up shaders, Workbench gives him opportunity to debug what is going wrong with by switching the debug channels. So we have it in enfusion, but also in Blender. Yes, so this was the mask for the masking all those 4 materials on PBR multi. Yeah, last level, the texture baking. So typically, all the upper or maybe lower LODs, they use like high-res textures, but for the last one, the worst one, all the doors and windows has to be baked in the texture because, as I showed you, like the base mesh of a charge was just without doors and any additional stuff. And yeah, you can hear it here. You can see it here. Yeah, this is the prefab with all of them. Yeah, and so one of our artists actually found a handy usage of material preview feature. So he basically imports all the necessary assets in the blend file and bakes it into the texture, into a low-res texture. Okay, another feature is terrain import and export. So we can import it from World Editor to Blender, do some changes, and get it back to World Editor. And even though our World Editor has terrain sculpting tools, sometimes we need more precise editing. For example, sticking a custom-shaped mesh via geometry nodes. But this one is a stupid one, but here actually you can see that the terrain elevation is split two lanes, each having a certain slope to help testing and configuring physical properties of vehicles. In other words, how vehicles' engine supposed to behave on a certain slopes. So this is one of the possible use cases for the terrain import and export. We also support P3D import. P3D is a mesh format for real virtuality engine, and basically old Arma community has made thousands of assets saved in this format through the years, and they would like to convert their creations into Arma Reforger, so they just need to import the P3D files into Blender and set up meshes and export them into FBX. Next one are object tools. Object tools helps quickly sort objects into collections. I already showed you in FBX import. Yeah, and also, as I mentioned before, colliders have to have their properties set up so physics, sounds, particles work correctly when player interacts with game objects, and EBT provides quick way of setting properties by retrieving lists of the settings from Workbench. I will talk about this retrieving thing in a moment. So here. Yeah, so here you can see a list of all available layer presets, and when user picks it, its objects gets it set via custom property. And here are the game materials. The hash or unique ID at the end of the material's name helps to pick right material from a resource database when importing asset into enfusion. Animation export, so user can make multiple animation within blend file, and via EBT he can choose which ones to export at once. Yeah, so we support also export profiles. This basically defines which bones per each animation will get exported. So for example, yeah, you can see them here. For example, user may want to export full body animations or just restrict it to upper body. And we also support the additive animations. Cool thing is that once animation or any asset is registered in enfusion, it's just about saving it and just switch to Workbench, and it updates automatically, so it speeds up the prototyping stage. Yeah, so as I mentioned about the retrieving the information from enfusion. In the first version of enfusion Blender tools, we were retrieving all the necessary information by parsing text files. The following, this one is material or the shader to get all the material properties, so we can import them via material preview feature. This one is meta file. That's an enfusion mesh. A meta file for enfusion's mesh object. Among other information, it holds also a mapping of material name in Blender to material used in enfusion. That's the assigned material. And this is the list of layer presets we use to fill a drop-down menu. You could already see with the settings. Okay, and so for the next release of Enfusion Blender tools, we decided to let EBT to communicate with Workbench via a TCP/IP protocol. So the way of retrieving data is solid and future-proof. Internally, we call this feature Bridge, and it's part of our upcoming release. So it works the way that we send requests from Blender with information what enfusion script to run and input parameters, and Workbench runs the enfusion script and returns the result back. This is how it looks like in Python. So the new way of connecting Blender to Workbench opens new possibilities that we are currently exploring. Here's one of them. This is a map in Enfusion, Enfusion's word editor that I use as a testbed for testing geometry nodes. Here is the same location in Blender, and yeah, by just dragging the density factor, we can generate points that represents trees location and just send them to word editor. It's basically a trivial demo, but you get the point where or how endless the possibilities opens up. Necessary to mention that in Enfusion we have great tools to generate forest, roads, even rivers. So this is really just some ideas what can be done with, for example, geometry nodes and the bridge support. And guys, this is it. Thank you for watching. Thank you for visiting. I'm not sure if there's some time. Okay, it's not. So let's meet afterwards.